So I think today I will go over number 1, number 6. It's about composition of function and inverse function. And then I wonder if I should just go ahead finishing it with number 7. I think I will. So let me rename it to number 1, 6, and 7. Therefore, we'll finish this one set here. Okay. Now, what is the domain of the function fx? That's all real numbers except 5/4. Right? I think that one is simple. Part B, find inverse function. Now, every time I ask you inverse function, I always want you to break it into that 4 steps. The first one, replace the fx becomes y. The second step, you swap x and y. The third step, you solve for y. So 4xy minus 5x equals y plus 2. 4xy minus y equals to 5x plus 2. Factor the y. So the y is equal to 5x plus 2 over 4x minus 1. But don't stop here. Don't stop here. Remember I said it's supposed to be 4 steps? Plenty of students actually forget the last step. The last step is inverse function. You have to rewrite it as an inverse function. 5x plus 2 over 4x minus 1. Is it okay, everybody? Now then, part C, find the range of the function or range of fx. Now, one way to find the range of fx is to find the domain of the inverse. Which is all real numbers except 1/4. Okay, just in case. You can just say a range of fx is all real number except 1/4. Okay, but the way you find it is by looking at the inverse function. Find g of f of x. So g compose f of x is g of f of x, which is g of x plus 2 over 4x minus 5. Now, what is my g again? 2, 3, 2, negative 3, 3, 4. That's 2x minus 3 over 3 blah plus 4. Let me check again. 2 blah minus 3. 2 blah minus 3 over 3 blah plus 4. Yeah, that's what it looks like now. Then from here, we will multiply by the LCD. Yeah, to simplify, right? Then we get 2 times x plus 2 minus 3 times 4x minus 5 big over 3 times x plus 2 plus 4 times 4x minus 5. Now from here we just simplify further, distribute, combine like terms. Okay, so this 2x plus 4 minus 12x plus 15 over 3x plus 6 plus 16x minus 20. That will be negative 10x plus 19 over 19x minus 14. Let me slow down a little bit. I may make a mistake. Maybe, I don't know. But the technique is correct. It's just, it is possible that I make miscomputation somewhere. I think I'm okay. So that's G compose F. Now then the next question is find the domain of G compose F. The domain will be all real numbers except look at the domain of fx first. Okay, notice that it's G compose F means it has to first able to get into fx. Okay, which means I need to avoid 5 over 4. Okay, now then after that we consider the composition in which we need to avoid 14 over 19. Okay, the domain of the G of F, you need to avoid those who cannot go into F. And then those who cannot get into the full composition F compose G. Now, part F, what is G compose F compose G? G compose F compose G is G compose F of Gx. Like you can write it this way first: G compose F compose G of X, and then you slowly work it in, right? What is F of G and then G of that? But I think that's way too long. That's way too long. Instead, we will use the fact that we already know G compose F. That's why I didn't want to make mistake there when I did part D. Now, once I get G compose F, then G compose F of Gx is the same to negative 10 G plus 19, negative 10 of Gx plus 19 over 19x minus 14. So this will be 19 of Gx minus 14. Is it there? 2 19s there? Oh, surprise. Okay, now then I will replace my G, negative 10 times 2x minus 3 over 3x plus 4 plus 19, big over 19 times Gx, 2x minus 3 over 3x plus 4 minus 14. Now, let me pause here a little bit and ask you to think about this. Is it okay? Now, anything after this is just simplifying process. Anything after this just simplifying process. Okay, let me go on. And from here, I multiply by the LCD, 3x plus 4 over 3x plus 4. Then we will get negative 10 times 2x minus 3 plus 19 times 3x plus 4 big over, let me write the separation first. Nineteen times 2x minus 3 minus 14 times 3x plus 4. That's negative 20x plus 30 plus 27x plus 76 over 38x minus, no, that's not 27, that's 57, minus 57 minus, that's 42x minus 56. Okay. So I get 37x plus 106 over negative 4x minus negative 4x minus 113. Yeah, to be honest with you, the last question is directed for how you play with this building block. But notice that in part D, we already did this part. That's for part D. This is part D. Okay? We did that part D. Now, if you put G in front of that, to the right of that means Gx going into that composition of function. Now, this is a side note. So what happened if I ask this one here? Note. What happened if I ask F compose G compose F instead? Now, then you can see that as F of G compose F, where this is what you get from part D. Okay, so you put that into F instead. Okay, so think of that as if it's a Lego, you know, think of that as a Lego. That's for number 1. Let's move on to number 6. Is there any question here so far? No question? Okay, let me go on to number 6. Number 6, on inverse function, the following functions are one-to-one. Find the inverse function of each. And I think these are a standard question. Part A is basic. Part B, not that simple, but still reasonable. Okay, part C is the difficult one. Okay, so basically part A is a bonus question because it's supposed to be question from intermediate algebra. Y equals to 2x minus 3 to the 5th plus 4. Step 2, you swap the x and the y. Step 3, you solve for y. X minus 4 equals to 2y minus 3 to the 5th. You apply 5th root. Okay, and then you add 3. Fifth root of x minus 4 plus 3. Now make sure the roof of this fifth root covers up to 4 only. Okay, and then I divide by 2. So maybe I make it the fifth root of x minus 4 plus 3 divided by 2 equals to y. Then step number 4, just to rewrite it as an inverse function. So inverse function of x is the fifth root of x minus 4 plus 3 big over 2. Okay. Any question? Let me go on. Part B. Find this function, the inverse of this function. Notice that this function is not one-to-one originally. It's a quadratic, right? So this is not one-to-one originally. Now we make it one-to-one by restricting the domain. Okay, we make it one-to-one by restricting the domain. Now then, what happened to the inverse? So step 1, y equals to x squared minus 8x minus 3. Step 2, I swap the x and the y. Now step 3, I solve for y. Now you have couple ways to solve for y's. One of them, you set it equals to 0, and then you use quadratic formula. So your A here is 1, your B is negative 8, and your C is negative 3 plus x. Okay, that's if you use quadratic formula. But I think here I will use completing the square method instead, because the leading coefficient y squared, it has coefficient 1. Okay, and then the coefficient of the y is even. So I will just do completing the square. So y plus 3 equals to y squared minus 8y. I will add 16, huh? So x plus 3 plus 16 equals to y squared minus 8y plus 16. That is x plus 19 equals to y minus 4 squared. Now then I will do the square root. I have plus minus here, right? Now that's the key part. That's plus minus. So if I add 4, that's what we get. Now then we proceed to step 4, right? We proceed to step 4, but I have some issue there. This is clearly not a function because you can easily find an x that gives you 2 different values of y's. Now that's a violation of the function, definition of a function, right? So the inverse here is not a function. Then where does it go wrong? The restriction, okay? The restriction. Because we didn't write down the restriction, right? When we swap, the x becomes y becomes x, then we have this new restriction for the y here. So you need to keep on writing it though. But if y is less than equals to 3, then which branch will this be? If you put this together, right? Okay, the y is plus 4 something or 4 minus something. Which of those two branches will give the y to be less than equals to 3? That will be the negative branch. Okay, that will be the negative branch. Is it okay? Now, even this one is not fully, it's not fully correct yet though. But at least you see that we get the inverse, right? We get the inverse function now. Which part is not correct? Which part is not correct? Here. The one I write in green was the one I did not emphasize to them, but I will start emphasizing that for you. Okay, we actually need to take a look when x is at most 3, what happened to the y? We know the graph looks like this. The graph looks like this, where the axis of symmetry is x equals to 4. Okay, now then, we are actually take this branch here. This is the branch we are talking about, up to this, up to that. So if we do the inverse function, this coordinate here later on will be that coordinate there. If we do the reflection with respect to x equals to y axis, then it will become something looks like this. Okay, but the thing is, this is not y equals to 4. So I want to point out like this. You know what? Let me just use the graphing. Let me just use the graphing. Give me a second. So this is y equals to x squared minus 8x minus 3. Is it right? Minus 3, I believe. Okay, that's what it looks like. Oops, too big. Now, how to graph the inverse function? How to graph inverse function of this? Let's get the inverse first, which is not a function. I will get the inverse of this function, which is not a function. It is by reversing x becomes y, y becomes x. Now, this is the inverse. Too big. Okay, well, like this then. Let me screenshot that and bring it back to our node. Let me erase this first. Now I want to put that picture here. I wonder if I can do it. Oh yeah, that's right. It's doable. So what happened is this. With the restriction in part B here, you want something less than -3. So this branch here, right? This branch here. Take a look on the y component. Take a look on the y component. You see, the x is less than equals to 3. such that the y will be some negative number to some positive. When we do the inversing, then you will see this guy here will get to here. In other words, the x is not from negative 19. If I don't do the restriction on here, if I don't do restriction on the x here, then the natural domain will be x from negative 19. You see what I mean? Okay. It will be from here and on, right? But I'm supposed to put restriction on my x here in the inverse function. Okay. Now, therefore, I need to find out what is the x supposed to be here. It will be like this. It will be x greater equals to something. Okay. But what will that be? Let me use green color. It's only 3-point questions. Therefore, I didn't hold this against students at that time. But it's supposed to be with this, where for x greater equals to something. Now, what is that greater equals to something? Then we look at what's the y here. What is f3? 3 squared minus 8 times 3 minus 3. That's 9 minus 27. That's negative 18. So f3 is negative 18 here, right? So the range of the original function is from negative 18 to positive infinity. That's the range of the original function. That should be the domain of the inverse. That should be the domain of the inverse. So starting from negative 18 and on. If I don't do restriction in my inverse function, then the natural domain will be from negative 19. Right? Okay. Now, but then we know it's supposed to start from negative 18, not from negative 19. Okay. So the part that I mark in green here, this part, the part that I mark in green here is the place where I give one student actually extra point for observing that part. Okay. Let me erase this, erase this coloring. Okay, this is the one that for those students who, there was only one. For those students who observe this, I give them one extra point. Okay, and the explanation is from what I did here. Okay, now let me go on to the next one, the next question. I hope I have enough space up from up there. I should be. Okay, part C. Find the inverse function of this fx equals to 2 minus square root of 3x minus 4. Step 2, x equals to 2 minus square root of 3y minus 4. Step 3, I solve for y. So square root of 3y minus 4 equals to 2 minus x. I will square both sides. This is where it becomes an issue later on, because squaring both sides will give us squaring is not a one-to-one function. This will be 2 minus x being cubed plus 4 over 3. Now notice that this is not one-to-one. This is not one-to-one. I can easily find two different x's that give me the same y, right? I still have I still have the inverse function though. I still have the inverse as a function. The problem is something not right here because this function is not one-to-one. While we know if a function is one-to-one, then the inverse is a function and also one-to-one. Let me write it down again. Let me write it down again. Every function has an inverse. Okay, how to find the inverse of a function? You just swap the x and y, you are done. That's the inverse of the function. But only one-to-one function has its inverse as a function. Now, if the inverse is a function, we call that inverse function. Okay, so not all inverse is a function. Not all inverse is a function. Now, the thing is, if the inverse is also a function, then it is one-to-one as well. Now, this is where it breaks down. Okay, I have this function is one-to-one. So the inverse is also a function. I have the right to use the functional notation here. Okay, but the issue is it is not a fully one-to-one. It's not a one-to-one function. So there must be some restriction on this inverse function to make it one-to-one. Now the restriction actually happens implicitly in the original function. Okay, it is that the y is at most 2. Right? How do you know that, Thomas? From here, you see this is 2 minus something, right? This is 2 minus something. And you will subtract by something 0 or positive. It means the y is at most 2. Now, that's the one you need. This is y at most 2. When you swap that, it becomes necessary. Swap the x becomes y becomes x, right? I hope now you see it becomes a one-to-one function. One-to-one inverse function. Basically, an inverse function has to be one-to-one. If the inverse is a function, it has to be one-to-one. Now, that's the part that was not emphasized in your intermediate algebra. Okay, now let's take a look on the graph. Let's take a look on the graph to convince you that what you wrote originally is not the perfect inverse. So originally we have 2 minus square root, where's my equation? 2 minus square root of 3x minus 4. So that's what the function looks like, right? And it is one-to-one. Now then, the inverse supposed to look like this. That's what the inverse is supposed to look like. Let me zoom that in a bit more. Okay, that's what the inverse is supposed to look like, the red one. Now, however, when you try to solve for y and write it as the inverse function, you rewrite that as y equals to 1/3 times parentheses, what's that? X plus 4. Oh, I'm sorry, x minus 2 squared plus 4/3. You see that? That's not the perfect inverse function. I hope now you see the issue. Okay. Now that guy is not, it's supposed to be part of that only. Okay. It's supposed to be part of that blue graph only. It's supposed to be part of that only. Let me change this to yellow. Now, this is a better view, I believe. Okay. That's a better view. Let me screenshot that. And insert that in our notes. Let me put it at the far back here. And say that that's for number 6C. Number 6C, let me screenshot. Hold, give me a second. I want to screenshot this. Okay. So you see that the original graph of the function is the one in purple. Okay. And then the inverse function supposed to be the one in red. Supposed to be the one in red. Supposed to be the one here. Supposed to be the one here. That's the real inverse function. Notice that the inverse supposed to be 1-to-1, right? Now, however, if you don't do restriction, you end up getting something more than just the inverse function. That's the one you see in yellow. Okay, that's what happens if you don't do restriction. Now, so these questions, number 6, part B and C, seems to be very innocent. Like a lot of students can actually do up to step 4 without realizing what's wrong, how incomplete their answers. Okay, they were missing this part here. Okay, and missing this part for part B. Now, some students able to do part B, and I give them full point even without this restriction here. Okay, it's only 3 points, but if I give them 4 points for this question, that extra 1 point is for this. Okay, now let me go on to number 7, the last question for this section. At least then, starting from now, you have one full old test that you can study from. Number 7, you have fx equals to an exponential function minus 2. So find the x-intercept. The x-intercept, by the way, the y-intercept should be easy, right? Y equals to 2 to the power of 0 plus 3 minus 2. That's for just the purpose of graphing. 2 cubed minus 2, that's 8 minus 2, that's 6. So the y-intercept is 0, 6. Okay, for x-intercept, that will be set the fx equals to 0, and then solve for x. It is a one-to-one function, right? So the exponent, if the base the same, then exponent must be the same. So x is negative 2. So the x-intercept is negative 2, 0. The asymptote, this is y equals to negative 2, which we get from here. Yeah, that's the exponential function whose horizontal asymptote originally is y equals to 0, and then you move down 2 units. Okay, now how about the range then? Some little observation. You can just give a one-line solution, but let me tell you first the reasoning. 2 to the x we know is greater than 0. So 2 to the x plus 3 is still at least 0, not including 0, greater than 0. But then when I subtract by 2, then that function must be greater than negative 2. So the range here will be negative 2 to infinity. You don't even need to show the work. The work that I show you here, you don't even need to show it. But if you wonder why it is true, that's the explanation. Okay, now then sketch the graph of fx. We have x-intercept negative 2, 0. X-intercept negative 2, 0. Y-intercept 0, 6, as I remember. Okay, and then the horizontal asymptote y equals to negative 2. And the 3 important coordinates. Those 3 important coordinates are from 2 to the x, this guy, this guy, this guy. Those are the 3 important coordinates for 2 to the x. Now, move that with the movement 3 units to the left and 2 units down. So for example, the original y-intercept, when I move 3 units to the left and 2 units down, this will be the new house from the original y-intercept. Okay, let me erase that, the shadowing, so that we don't get confused, or at least we know then we are done with that coordinate, moving that coordinate. Okay, now then how about this guy here? 3 to the left, 2 units down. Oh, that's one of our important coordinates that we got originally. So I can erase this right now. And then this guy here. 3 to the left, 2 down. So it should end up there. So here. Now we have x-intercept, y-intercept, and 3 important coordinates. Then I can graph this now. So it will be approximately something looks like this. Now, if you graph this without graphing paper, if you happen to not to print it out, but you use your own blank paper, then you need to put the coordinates. This is -4, -1.5. Okay, if you don't have this graphing paper, if you do like what I have here, then you don't need to put it. You can if you want to, but you don't have to. Okay, because where you bubble the dots is clear enough for me where you put it. Okay, so at the same time, please do not rescale the graphing paper. Okay, do not rescale my graphing paper. So this is the end of this fall test 2, the one from last semester. Any questions so far? No question. Okay, let me move on to spring 20. We will do number 1, number 6, and then number 7. I will do number 1 and then give myself a little break. Okay, but at that time, then I will show you number 6. I would like you to do some problems from number 6 on your own before I go on. So number 1, what's the domain of fx? The domain of fx is all real numbers except 5. That one is easy. Step 2, what is the inverse of fx? Inverse function of fx. Step 1, replace fx becomes y. Step 2, swap x and y. Step 3, solve for y. So xy minus y equals to 5x plus 2, factor the y. So y is equal to 5x plus 2 over x minus 1. So step 4, the inverse function is 5x plus 2 over x minus 1. Now, the domain of that inverse function is the range of the original function. That is all real number except 1. Okay. Now, what is G compose F? G compose F of X is G of Fx. That is G of 2x, G of x plus 2, x minus 5, G of x plus 2 over x minus 5. Now, what is Gx again? X minus 3, x plus 4. So as a little note here so that I don't need to refer up there again, x minus 3 over x plus 4. Let me see up there. Yeah, that's right. Then what is G blah? G blah will be blah minus 3 over blah plus 4. Okay, now then I multiply by the LCD. I wrote it the GX there earlier so that I don't need to refer above. It can be confusing for you as a reader or the watcher. But I erased that right now so that I don't need that anymore. I don't want it to take the space I need to finish this problem or the next problem. So I multiply by the LCD on the top and the bottom. I get x plus 2 minus 3 times x minus 5. And then at the bottom, we'll have x plus 2 plus 4 times x minus 5. Distribute combine like terms. X plus 2 plus 4x minus 20. That is negative 2x plus 17 over 5x minus 18. So I need to avoid all real numbers except 18 over 5. So the domain of that G compose F is all real numbers except 18 over 5, right? Except 18 over 5. But I also need to avoid the number that fx avoid. That is, I need to avoid 5. So this 5 here is coming from that f. Okay. So what is G compose F compose G? G compose F compose G of X is equal to G compose F of Gx. Okay, now notice that we already did from part D, G compose F. G compose F was negative 2x plus 17, 5x minus 18. Negative 2x plus 17. So this will be negative 2g plus 17 over 5x minus 18. That's 5g minus 18. Right? So I replace this gx here. Okay, and F compose G is that. Now everything after this is algebra. Okay, x minus 3, x plus 4. So this is negative 2 times x minus 3 over x plus 4 plus 17 over 5 times x minus 3 over x plus 4 plus, minus 18. Now everything after that is again just algebra. So multiply the top and the bottom by x plus 4. That gives us negative 2 times x minus 3 plus 17 times x plus 4 big over 5 times x minus 3 minus 18 times x plus 4. Okay, then from here, just simplifying, distribute, combine like terms, negative 2x plus 6 plus 17x plus 68, big over 5x minus 15 minus 18x minus 72. That is 15x plus 74 over negative 13x minus 87. Okay. That's for number 1. I think this is the second time we do this, the third time, including from the one from spring 19. Okay. Now then let's see number 6. I would like you to do number 6. Where's that number 6? Here. I wonder if yeah, that's number 6. Oh, okay. I hope this is better visible. See, is visible better. Okay, this is number 6. Let me ask you to try number A and part B. If you have a chance to go to part C, go ahead. But let's take 10 minutes break plus 10 minutes to do as much as possible from this number 6. Okay, so I will come back at 10:53. At 10:53, we will do this ABC. Okay, 10:53, we will do this ABC. Okay, go ahead, take your break and come back in 10 minutes. Or you do this first in 10 minutes and then take your break, either way. I'm sorry, I forgot to record this. Yes, this is for 6A. Good thing it's nothing really special from here. Straightforward. Like B and C is where we start having some issue. For part B, suppose we have this function here. And we have restriction. So step 1, y equals to x squared minus 6x plus 1, where the x is at most 3. So, oops. Step 2, x equals to y squared minus 6y plus 1. That's for y is at most 3. Now, before I forget or before you lose track, let's take a look what will the y be. So this is something with the axis of symmetry is x equals to 3. So it's like this, right? Okay, and then that's for x less than equals to 3. Okay, so the y will be from the vertex, right? The y will be from the vertex. What is the vertex, by the way? So when x equals to 3, so f3 will be 9 minus 6 times 3 plus 1. That's -8. So our domain of the inverse later on will be, the domain of the inverse later on will be x is greater equals to -8. Now, if it is embedded naturally in the function, then we don't need to write it. You can if you want to, okay? But if that's not our natural domain of the inverse, then we need to say that explicitly. So step 3, y minus 1 equals to y squared plus 6y for y is at most 3. X minus 1 plus 9 equals to y squared minus 6y plus 9. For y is at most 3. So x plus 8. Yeah, x plus 8 equals to y minus 3 squared. When I do the square root, I get plus minus square root of x plus 8 equals to y minus 3. For y is at most 3. Now, then the y is 3 plus minus square root of x plus 8. For y is at most 3. Now, from here, we see that the branching together with the restriction give us y has to be 3 minus square root of x minus 8, right? Okay, and then step 4, inverse function is 3 minus square root of x plus 8. Now, how about the domain of this inverse function? The domain is at least negative 8. So the range of the original function that we have, turns out to be the natural domain of the inverse function. So because of that, you don't need to write this down. Okay? Yeah, let me write it as a shadow instead so that you see what happened there. So this is y is at least negative 8. This becomes x is at least negative 8. Now x is at least negative 8 in the inverse turns out to be the natural domain. So I don't need to write it explicitly anymore. But if you do, you are fine. Okay, if you do, you're fine. Okay, now part C. Find the inverse of this function. So step 1, y equals to square root of 2x minus 3 minus 1. Notice that the y is at least negative 1. Right? The y is at least negative 1. Okay, when I square both, when I swap, then this becomes x is at least negative 1. So x plus 1 equals to square root of 2x plus 3. So x plus 1 squared is equals to 2x plus 3. But don't forget the x is at least negative 1. Okay, so x plus 1 being squared minus 3 over 2. Oh, I'm sorry. What happened with me? This is supposed to be y here. So this is equals to y. So step 4, y equals to, f inverse is equal to x plus 1 squared minus 3 over 2, which is not a one-to-one function until I put this restriction. Okay, so you need that restriction right now. Basically, at the end of once you're done with your inverse function, check 2 things. Okay, first one, is it a function? Okay, is it a function? Okay, if the inverse is not a function, then take a look on the restriction. Okay, second, you need to check if it is one-to-one. If it is not one-to-one, take a look also on the other restriction. Okay, so it has to be a function and it has to be one-to-one. Okay, for the inverse function. Okay, that's for number 6. Number 7. Huh? I don't have number 7 here? Only this long? Hold on, I did not include. Oh, I remember now. So at that time, I didn't include exponential function because we were behind schedule for that time. Oh, well, I thought I have number 7. Okay, that's fine. Let's move on to spring 19. So we are done with spring 20 by surprise. Okay, spring 19. We did part of that already. Okay, we did most of. In fact, we did all of the problem here. Number 2, we did it for test 1. Okay, number 3, we did it for test 1 in my review. Okay, and then 4, 5, we did it in test 1 also. Number 6, we did last time, like last week, I believe, on Monday. Okay, number 7, 8 was done last week also. And number 9 happens to be the same question with spring 20 test 2 number 4. Okay, so for this guy here, I will do number 1, B, and C. And yeah, B and C only. So this is for number 1, B and C only. Regarding the inverse function and the range of the function. Is this the same question with spring? No, I don't think so. No, I don't think so. I just feel like I did this problem before. Yeah, so part B. Or part B, step 1, y equals to x minus 3 over x plus 4. Step 2, x equals to y minus 3 over y plus 4. Step 3, solve for y. At this point, you must get used to these basic problems already. Now, I'm not saying that in your test later on, I won't have any other type of problem. Okay, but for you to be able to do other type of problem, you need to know how to do these basic problems first. Okay, the one I gave that in spring 20, fall 20, this fall, spring 19s are basically no curveball. I don't give hard problem. I don't give problems that, you know what, you never see this before in class. Okay, so for them, they saw that, they saw these questions already in class. So numbers, I'm sorry, not yet, not step 4 yet. So y is equal to negative 4x minus 3 over x minus 1. So step 4, f inverse x is negative 4x minus 3 over x minus 1. Okay, now it turns out that on the top, we can factor the negative. Okay, on the top, we can factor the negative. So it is possible if you do slightly different method, not slightly different method. If you happen to move different things, suppose you move this 3x, the 3 to the left instead. If you move this 3 to the left instead and xy to the right, then you will get, for example, in this case, you will get 4x plus 3 over 1 minus x. That could be what you get. Okay, but they're basically the same. They're basically the same. Okay, they're basically the same. Yeah, because if you, the negative cancels with the denominator when you reverse the order of subtraction. Okay, now part C, what is the range of the function? The range of the function is equals to the domain of the inverse, which is the all real number except 1. That's it. You're done. Okay, now how about spring 19, test 3? Let me see which question we have done. We have done number 1, number 2, number 3. I think we should be able to do number 4. Number 5 will be for test 3. This is test for test 3. For your test. Okay, let's check further. Yeah, this is for test 3. This is also for test 3. Okay. I believe we fully done with the exponential function on Thursday, right? Let me check. Give me a second. Oh, I didn't fully do exponential function last time. Yeah, so I did only solving equations and the basic exponential function. Okay. But in your current test numbers, I believe number 7 here. Okay, and what I'm about to do with the Spring 19 number 4, I assume you know how to continue from your basic exponential function and then do transformation. Okay, basic exponential function and then transformation. Now let's do this one. So what is the y-intercept? Y-intercept is f0. I need to change the date here. Give me a second. I forgot to change the date here. The properties. Now I change this to April the 5th. Okay, now then this is 2 squared minus 8. That's 4 minus 8, which is -4. So the y-intercept is 0, -4. That's easy. The x-intercept, you set the y equals to 0. 2 to the x plus 2 minus 8. 8 equals to 2 to the x plus 2. That's 2 cubed. Therefore, 3 equals to x plus 2. X is -1. So the x-intercept is -1, 0. What is the asymptote? Y equals to -8, right? Y equals to -8. How about the domain of exponential function? The domain is all real numbers. That's easy. How about the range of that function? The range starts from the asymptote, not including the asymptote. Now then, I need to sketch that. The y-intercept 0, -4. Y-intercept 0, -4. X-intercept is -1, 0. -1, 0. Why doesn't look like the way I want it, suppose? X-intercept. Oh, sorry. The x-intercept is 1. Why I have that extra negative? Oh, my bad. So that's 1, 0. X equals to 1 here. Okay, so no, it's not here. It should be here. I know it's supposed to be increasing. So earlier, if that were -1, 0, it becomes decreasing. But no, not supposed to, because the base is 2. And we don't flip that upside down, or we don't flip that with respect to the y-axis, which I plan to do in your next test. So in your next test, be prepared with this kind of question. 2 to the, let's say, 3 minus x, let's say, plus 1 or minus 1. Okay, or anything else. So the graph of this one I'm talking about, is 2 to the x first, and then 2 to the x plus 3. You shift that 3 units to the left, and then you reflect with respect to y-axis. Okay, so you reflect with respect to the y-axis, and then you move down. Then you move down 1 unit. So originally that's 2 to the x, which you move 3 units to the left, and then you flip with respect to the y-axis. Okay, now only those students who watch this video in the entirety knows that I plan to do so. Okay, so you still need to know how to do your transformation though. Okay. Now then, The horizontal asymptote is y equals to -8. And then we need to talk about the three important coordinates. Okay, three important coordinates were this guy, this guy, this guy. From the original 2 to the x. From the original 2 to the x. Okay, now what happened to those three coordinates? If you can put more coordinates, that will be great. Okay, but at least these three. Now, let's start with moving it 2 units to the left and 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. So the new coordinate later on will be here. That's for this one. Okay, now how about 1, 2, 2 units to the left, 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. That's the new location of 1, 2. How about the new location of -1, 1/2? 2 units to the left, 8 units down. 1, 2, 3, 4, 5, 6, 7, 8. Here. So the new location is here. Now using those three coordinates, then I can sketch the graph better. And the one to the left will actually dice down like that. That's what the graph approximately look like. Okay, that's for this exponential function. And I'm actually done with 3 sets, I can say, like 3 sets of previous test 2. Okay. What I plan to do then in the next meeting, I would like you to do this at home first, okay? I would like you to do this at home. Let's decide which test to look at. Let's see, which semester to look at. Spring 17. Let me see their tests. I forgot if their test 1 already include everything. I'm sorry, I'm kind of like not remember fully which semester I taught. How about fall 19? Did I teach that? Fall 19. Yeah, fall 19. Let's say test 2. Give me a second. There's a chance this is the same test I gave. Yeah, this is the same test I gave in spring 20. Oh, no. Or maybe yes. Yes, I think this is the same test I gave in my spring 20. Let me compare it to spring 20, okay? Spring 20, number 3. I have 12x at the end. Oh yeah, that's exactly the same. So no, we cannot use spring 19. I mean fall 19. Cancel that. My bad. Let's see more. If I look back further, then how about spring 19? Do I teach that class? No, I don't teach that class. How about fall 18? Fall 18, I don't teach this class. No, how about spring 18? I'm sorry. I'm trying to look back further. I don't teach this class. That's spring 18 and fall 17. I don't teach this class, but I teach Precalculus at West LA College. So let's take a look there, test 2. I wonder if we did this question already too, because I usually just, oh, this must be new. This must be new. I know for sure this is new. I know for sure this is, we never did this. Yeah. Okay, so what I want you to do on this Wednesday is you work on this fall 17 Math 260 test 2. Okay. So what happened is this. On Wednesday, I plan to go over this in the entirety. Okay. For the purpose of students who don't really follow us until a couple days before the test, at least then they still have the recording. But for you, you can ask me question, Thomas, can you do number 2 first, right? Which I may not do it, but at least I know that, oh, Mr. So-and-so or Miss So-and-so have some difficulty in which question. Okay, that's for fall 17 Math 260. Let's take a look on fall 17 Math 260 test 3. I know that includes exponential function and supposed to be inverse function. We may have done inverse function some earlier, but let me take a look. Fall 17 test 3. So there, fall 17 test 3 has exponential function. Part A. Part B, we will not touch it on this Wednesday. That's logarithmic, which is what you will learn tomorrow. Yeah, I will start teaching. I will finish up exponential function topic tomorrow. I think that's 4.2. And then go on with 4.3. And you will be able to do, supposed to be able to do number 3. You can try. Okay, so for this fall 17 Math 260 test 3, I give them 5 tests on that semester. So the curriculum is slightly different before I start streamlining. This one is a bit tricky, but actually on the easy side. Tricky on the easy side for that number 3. So I highlight the one you should be able to do. You should be able to do this at this point. Okay, number 7. These are the trigonometry part. Yeah, so please work on these 3 questions from fall 17. Fall 17 Math 260 test 3. Fall 17 Math 260 test 2. You should be able to do number 1, number 2, number 3, number 4, number 5, number 6. Yep, basically all. Okay, that's what we'll do on Wednesday. Fall 17 Math 260 test 2, all of them. And then fall 17 Math 260 test 3, number 1, number 3, number 7. I will post the file on our discussion board. Okay. And that's for today. See you then on Wednesday.